in Java is kind of very interesting. Now we get to talk about two different types of strings called a string builder and string buffer. Okay, these are special types of string that you can use for your program. And I put here, basically you're going to just cut and paste this right out of the textbook about the string builder and string buffer classes. Okay, so the string is also a class. That is why we told you from the first week that, or second week, is that the string, if you declare a string, you always use the capital S, right? Because it's a class. All the other types, like the characters and integers and int and boolean, they all are primitive types, including strings. But they also have their own classes as well with a capital letter, and you have to spell the whole word like integer instead of just int. They have classes also. Those are called wrapper classes because what it is that actually in that class you wrap the actual primitive type inside it, so you can still use it as a primitive type. But once you use a wrapper class, then you have access to a whole list of other functions you can use to manipulate that data. Just like strings, like when you declare a string, you can change it to uppercase, lowercase with the dot notation because you have all those built-in functions into it. Whereas if you just use like int, you don't have that option because it's very primitive. Okay, unless you use the keyword integer I equal something, then yeah, I now has all those functions as well, or their own function to do it. So I put in color here the word immutable. Okay, string is immutable. That is a term that it's really hard to grasp, to understand, until I guess it takes a while to really understand it. It took me a long time to understand it, really, until I looked really deep into Java itself and learned about the constant pool, what it is, and about a heap and stack and all those stuff. So I'm going to try my best to explain what that is to you so you understand, so you get it, because chances are this will recur again in the future if you go into programming. Okay, either the term mutable and immutable. Okay, so we'll find out what that means. So right off the bat, string builder and string buffer classes are both mutable classes. Okay, or mutable. The only one's not is just a string, and we'll see why. And there's a really good reason why string is not mutable. Okay, so character, I think we know what character is, right? It just stores a single ASCII character in the ASCII table, so you cannot store more than 2 characters, just one at a time. And you always wrap a character with a single quote, not a double quote. Okay, very different from, I guess, other languages. Well, they are dynamic, but to the Java, it's just a single character, single quote. When you declare it, you use the lowercase chr, like char, right, or car, however you want to pronounce it. But it also has a character class with a capital C, and again, you have to spell the whole word like this. Now, if it's a class, so again, it wraps a value. So it's another term for a wrapper class. Okay, anytime you hear the word wrapper class, means you actually wrap the actual data or the primitive type inside it. So it's contained within that class, and then now you can manipulate that data using some built-in function inside the class. Okay, so it wraps it inside it. So so you have all these types: the integer, the double, the byte, and boolean, and so on. So the character type is, so once you use that character class to define your character variables, then you have access to these built-in functions. Okay, otherwise, if it's not, you don't have access to these, like uppers and lowercase and so on, because they're very primitive. You can check. You can change the uppercase, lowercase. You can check if it's a digit or not, if it has both or the other, if it's a white space or not. You can check those for validation purposes. Okay, so this is very simple. So I'm not going to spend time doing this one. We're going to talk about the strings. Okay, again, this term here again, string is immutable. So let me color that. Okay, so before we talk about string further, I want to show this diagram here. This thing about a constant pool. This is what happens behind strings when you declare a string variable in Java. Okay, we have a thing called inside the JVM. It's like in RAM, or the memory, something called a string constant pool. It is like a pool of constant data, and those constant data are all like string data types. Okay, so if you look at this diagram I have here, I kind of borrowed this from somewhere. I have a pretty nice drawing to it. Okay, so if you look at this orange circle here represents a memory address inside RAM, and this orange represents the memory type called heap. Okay, if you think of heap in a stack or like heap of straw, something like that. If you lost something in a heap of straws, it's almost impossible to find it because it's so hard to get it, right? So if you store data in a heap, in memory in a heap, so I mean that's what it represents. Data is contained in a heap means randomly in that random space. It's kind of hard to explain. But what we're looking at is this green box here, green circle here. This is called the constant pool, or the string constant pool. So every time when you create a variable of string type, okay, it's not the string buffer, string type, and if you assign a value like the second one here, like Java5, okay, string 2 is equal to Java5, that text. And what happens behind the scene is that, so the JVM, the virtual machine, will go into this constant pool and search in there if there is existing a string already called Java5. Okay, if there is one, then this white circles in here is actually an object inside that space, so containing that value called Java5. So if that's already existed, then what JVM will do is that instead of creating a new object, it just use that same object and reassign the memory address of this object to that variable called str2. Okay, so now str2 has the value Java5. Okay, and then you have another string called string4, and you also assign the same value Java5. Well, the same thing happens. JVM goes into the constant pool, see there's one already, oh there it is, it's one. It assigns that same number or same address to string 4. Okay, so that is why when you do this way and you compare string 2 equal string 4, you get true, because they're pointing to the same object, right? You're comparing actually not the value, you're comparing the memory address of that white circle there. Okay, and that's why it works. And the way we just think is, oh, we are so used to like number equals 1 equal 1, that's true, and string should be the same. Actually, string is a little bit different. Okay, it's actually very different. So you're actually comparing the memory address of this object here in the constant pool. So if I have another string called string 10, and if I assign that to Java5, well, guess what? That's going to point to the same object here. As long as there's one inside that memory space, the constant pool, JVM will reuse that over and over again. So in that way, there's only one object existing inside the pool, so it doesn't consume memory. Okay, so that is the whole thing behind strings. And then, so if string 2 and string 4 are pointing to the same object, this is kind of similar to another concept. I'm not sure if I explained to you before or not, but about reference type and the non-reference type of data. Okay, so if you look at it looks just like, okay, so if I have S2, change the value from Java5 to Java6, so therefore string 4 should also contain Java6, right? You would think, but it doesn't happen that way. Okay, so let's just say, okay, well, if I change string 2 to say Java6, well, it goes again, JVM goes into the pool, look for a Java6 string. Is there one or not? No, there's not. Well, JVM creates another object. It's a new object this time, contains the string Java6, and then the pointer for string 2 is now moved to that other object. Okay, so therefore you can never change the internal object's data. So that's what immutable means. Immutable means you cannot change its data. What data? The data contained inside this pool here. Okay, so that's immutable. That is why when I change S2, string 2 and string 4 points or has the same value, later on, if I change string 2 to a different text, they no longer point to the same object. Okay, so you can't change it. Not only that, so every time when you create a new string, a new assignment to the string here, Java actually recreate that variable all over again. Okay, it recreates a complete new object or new data again, and then stores that new data here. Okay, so that's immutable. And JVM does this. I thought it's pretty smart because you save a lot of memory. You don't have to waste a lot of RAM because maybe you put Java 5 and then you don't use it ever again, and that stays in there for a long time. So you don't waste time. RAM. So that's how it happens. When you declare variable this way, okay, literally you should say string 2 equals Java 5. If you do it the way like string 1 is string 3, if you do it that way, now it's different. Now you are the difference is that the object being created, it's not inside the constant pool anymore. It's inside the heap memory location here. Okay, it's outside of it. If you do it this way, and that's just how Java interprets it, it does it. And then when you do it this way, so even though string 1, using the new string constructor to create that string, it has the same value as Java 5. When you compare string 1 equal string 2, and that's why we tested it before, it's also on the exam, and they were not equal because if you look at these two white circles, oval shapes here, they are not pointing to the same object. Okay, it's a different memory space completely. So therefore, this out here, string 1 has a different memory address compared to the object in here. So we compare the object references; they're not equal. And so in order to check the value, you have to use the string equals function, right? We don't want that before. Okay, so that is the reason behind immutable strings. Okay. Let's kind of show you here a little bit. But let's talk about mutable strings. I'll show you a little bit later when we do it in the example. Now, the mutable strings are the string buffer and string builder. These are special classes that is used primarily for strings also. And they are mutable because their data can be changed. Okay? And if their data is changed, then it affects all the other objects that share the same data. Okay. I mean, if A and B point to the same data, and if A changes, it does also affect B. Okay, that's mutable means. Okay, so basically that's it. Okay, but it has a lot of the built-in functions in both of these classes, and they both work very similarly. The only difference is it has to do with thread safe or not safe. Again, this is more advanced Java, but when you write threads and parallel programming, then they become really important because every time you generate a thread, it's like you run it on a different session, and they have the capability of interacting with the strings. So if you use one or the other, you get a very different result. And so that's why there are two types of string types: the buffer and the builder. One is thread safe, one is not. Okay, but in terms of just how you use it, it's identical. So you can choose either one. That's completely fine because we're not going to do any like thread writing in this class. And they're both mutable. And then we'll do examples of that. Okay, and here's a table that's kind of show their pros and cons. Okay, and between string and string buffer. Here I didn't put a string builder, but they're kind of similar. Okay, and it's down here. So buffer and builder. And these are some built-in functions or methods into the string class. Okay, so if you use a string, then you use this already. I think a few of these already been used. You can check if it's empty or not, right? You can check the length of that string by using the dot length. And again, all this is a function, so properties of the class called string, you can always use the dot notation. You can check for the, you can change to lowercase or to uppercase. Okay. And trim, you can trim white spaces both from both ends. I'm not sure you can do with just one end. I know that, like in Visual Basic, you can trim the front or the back or both sides. Java, I don't think you have left and right. You can concatenate two strings together. Again, this is a function, so you use the dot notation, right? So you, in this example here, here is a string, and the dot you concatenate, call a function, you pass a new string inside, and they'll be appended together. Okay. And then you can replace strings also, character by character. You can get a substring out of that string based on an index starting at a certain index if the string is unhappy. And if you want to get a partial or just a section of that string, then you can say, get me the substring starting with the index 2. Okay, so index 0, index 1, index 2, starting with this character all the way to the end of that string, so you get the word happy. Okay. So the number here is the index, the starting index position, starting from 0. This
starts at an index, but it always gets to the strings or another substring method.
Right. So the next one here, yeah, it's the same. So it's a
Oh, it's just an option.
So what is this? So the same string, yeah, different index variables or different signature. So what do you call this type of function? Oh, what do we call this special term? Right? You learned it before. It's the same function. It takes different parameters. Here it says 1. It takes 2 here. Yeah, these are like the method overload, right? Yeah, unique signature. Okay, so they are overloading it. So this one here. So if you only use one number, it's going to go from that position all the way to the end by default. There's no limit. It is the end of that string. If you want to pause at a certain area or select only a portion of it, then you use both numbers, the beginning, the starting position, and the ending position of that string. And if the index position at the end is, larger than that string, it's going to go all the way to the end anyway. Okay. So just want like 2 characters, then starting from 1 and end at 2. Right? If you just want 1, you just say from 1 to 1, and then you get that single character out. Okay. Here you also check strings and get the strings with a, you can start at a certain character. Okay. So ends with a certain character. You can, yeah, it starts with a character, ends with that character, or you can check the character at a certain position. This is for the character. And then you can also split your strings. You can split in half or in multiple strings, substrings. And when you do that, though, because you're splitting into multiple strings, so you have a multiple elements, and so therefore you have to store that inside an array. Again, we'll learn array next time. So this probably will come back again. And that is sometimes is very useful. So here's the equal we talked about, we used before, right? Put that next line. So the equal, here you were checking for the value for these strings, then you have to use the equals function. So you're now comparing the memory addresses. If you are comparing strings like this one here, and you want to ignore the case, then use equals ignore case. So that Apple here in all uppercase or lowercase, they'll be equal. In this case, it's false because Apple A is capitalized, so small a is not. So if you don't call this function, then case is important, right? Whereas if you call this one, then it doesn't care. So I mean, you would think that it doesn't care, but really behind it, it actually converts it to both the lowercase or uppercase already, right, for you. And the toString here is a function that you can use. You can also override this. Okay, you can override it so that you can have your own way of displaying data for object. And we'll do examples of this later so you can see how that works.